Here to solve the question paper of UPSC optional physics 2025, and from paper 2 we are solving quantum mechanics. So the quantum mechanics problems we will be discussing today. So the question 1 is question 1 part A. It says we have a wave function phi x is bx square, and it says that the function exists between x0 to 2 and it's 0 elsewhere. So the first thing we have been asked is the probability that this particle exists between 1 to 1.5. So ठीक है, तो सबसे पहले हम यहाँ पे देखें तो the wave function is not normalized, so we can normalize this function. So normalization condition अगर इस पे अपन लगाएंगे तो we can write minus infinity to infinity psi x square mod dx is 1. So here the limit is from 0 to 2. So 0 to 2 b square x4 dx is 1. So it's b square x5 over 5. So x5 over 5, if we put limits, this will be 2 power 5, which is 32, minus 0. It's 1, so b is root 5 over 32. So the function here is 5x. Normalized function is root 5 over 32 x square. So the first question, it says find the probability to exist between x is equals to 1 to x is equal to 1.5. So we can write easily here. The probability can be written as psi star x psi x, which is the limit is 1 to 1.5, and can be written as psi star x psi x dx phi. Actually phi, the function is phi here, so 1 to 1.5. The square of this will be 5 over 32. The square is x4 dx, so this will come out to be 5 over 32 x5 over 5, and if we put the limits from 1 to 1.5, this can be written as 3 by 2. So this will be 1 over 32, 5 will be cancelled out, and this will become 3 by 2 power 5 is 3 power 5 is 243 upon 32 minus 1. This can be written as 1 over 32 into 243 minus 32 is 211 over 32. So the probability will become 211 over, this will become 4 and 6, 96. It's 1024. So probability is 211 over 1024. So the question 2 is find expectation value of x. So we can find the expectation value of this function, this x. So this will be minus infinity to infinity. So the limit here is 0 to 2 psi star x phi star x x phi x dx, which can be written as 0 to 2 x phi x square dx. This will be 0 to 2. If we multiply this function with x and the square, we do square, so we get 5 over 32. X square is x4, there is extra x, so it's x5 dx. So this will become 5 over 32 into 1 by 6 x power 6, limit is 0 to 2. So here x power 6 is 64, so 32 64 is 2, 10 by 6, so it's 5 by 3, it's 1.66. so the expectation value is 1.66. so these are the two answers. First is probability and the second is the expectation value of x. Okay, आगे बढ़े हम अगर सेकंड क्वेश्चन पे. So we can erase this. This was very easy. Question number 2, we will be solving question number 2 now. Question number 2 says, actually it's part B of question number 1. So it says, so that square of orbital angular momentum operator, which is L square, commutes with any of the components of angular momentum operator. So you have to solve that L square Lx, any of these three, L square Lx or L square Ly or L square Lz. You have to solve that this is equal to 0. L square commutes with Lx, L square commutes with Ly and Z. So L square commutes with all the components Lx, Ly and Lz. So we have to prove any one of them. So let's start with this. So L square Lx can be written as Lx square plus Ly square plus Lz square Lx, and this can be further written as Lx square Lx plus Ly square Lx plus Lz square Lx. Now this will be 0, so we can write it as Lx plus Lx. This can be written as plus Ly Lx plus Ly Lx and Ly. This can be written as Lz Lx plus Lz Lx Lz. Now we know that this is 0, so this vanishes out. This will be 0 as well. So these two things are 0. So this can be written as, so these two terms are gone. Now we are left with Ly Lx. So Ly, we know that this operator Lx Ly is IH cross Lz. So Ly Lx is minus IH cross Lz. So minus IH cross Lz plus this operator will be again IH cross Lz. So it's IH cross Lz. This is Ly now plus Lz, and this operator is Lz Lx. It is IH cross Ly. Similarly, this can be written as plus IH cross Ly and Lz. So if you now see, we have all these terms here. This is Ly Lx and this is again Ly Lx. So it's a minus, it will come with a minus sign. Okay, so it's a minus Ly IH cross Ly Lz plus IH cross Ly Lz. So this term will cancel out with this term. This is minus IH cross Lz Ly. This is plus IH cross Lz Ly. So these two terms will cancel out. So this will become 0. So we have proved that L square commutes with all the with Lx, Ly and Lz. So this was part 1. Part 2 of this problem, first B, was that it says that is it possible to measure L square Lx? Is it possible to measure L square Lx, Ly and Lz? So we know that these two, any of these two will not commute with each other. So Lx, Ly do not commute, Ly, Lz will not commute, Lx, Lz will not commute. And we know that L square Lx is 0, L square Ly is 0, L square Lz is 0. So it's not possible to have simultaneous eigenvalues for all these. So these 4 cannot be measured simultaneously. We can measure L square and one of the component Lx or Ly or Lz. So the answer for 2 will be that L square, Lx, Ly and Lz, all these 4 cannot be measured simultaneously. Okay, so this was question 1b. Let's move ahead. So the part C and part D are from atomic and molecular physics. Part E is again from quantum mechanics. So question number 1, part E, it says that V of x is 2h cos square b square x square over m, and it says that the function psi x is e power minus bx square. So we have to find the energy of the particle. What is the energy of this particle? So we can see here that this particle is moving in a parabolic potential and the function is decaying exponentially. So Vx can be plotted as, we can plot V is basically like this, it's parabolic, and the wave function obviously is decreasing here, and it is decreasing like that because it's exponential. So psi x is decreasing, psi x with x, and this is Vx with x. So we have to find what is the total energy of this particle. So we can use Schrodinger equation to find the energy. So Schrodinger equation says minus h square over 2m d2 psi over dx square plus v psi is e psi. So we need the second derivative of psi. So from here we can write as first derivative of psi dash x is minus of 2bx e power minus bx square, which will be psi x itself, and the second derivative is psi double dash x is there are two functions we can use chain rule, so it's minus 2b psi of x. Now this will be minus 2bx psi dash x. So psi dash is this, so this will be multiplied with it, so this will become plus 4b square x square psi of x. So psi double dash x can be written as psi of x, and we can write 4b square x square minus 2b. So we can plug this value here and we can easily find the value of energy. So it says minus h square over 2m d2 psi over del x square, which will be this thing. So this is 4b square x square minus 2b, and we have psi outside, plus v psi. So we can put v here, so it's 2 h cross square v square x square over m psi is equal to e psi. So this can be further solved. So this will become, if you multiply this with this, so this will become minus 2b square h cos square x square by m, and if we take psi out of these two terms, the second term will be plus 2 will be cancelled out, so it will be b h square over m, and this is plus 2b square h square x square over m, and we have psi outside, this is e psi. So these two terms will be cancelled out, and we can compare and find that energy of this particle is simply bh square over m. This is the term for energy. So the potential was given and we have plugged all the values in Schrodinger equation and found out the value of energy. Now let's move ahead. So the next question is, it says, the question 2 part A, it says that prove L square Lz is 0. So this question we have already solved. अभी हमने solve किया था इसको, so it's a free question. So this has been repeated. So we get double marks for this. Very easy, very good. We have solved it. The second part is, this was the first part. The second part is prove that Lz L plus is H cross L plus. So we can start here. So it's Lz Lx plus iota Ly. We have to prove this is equal to this. So this can be written as Lz Lx plus iota Lz Ly. So this is basically Lz Lx is I h cross Ly plus I. This is minus I h cross Lx. So this is I h cross Ly. This is minus I square, which will be plus 1. So it's h cross Lx. So if we take Lx, sorry, h cross out of it, this will become Lx from here. This from there, this will be iota Ly. So this is basically L plus operator. So this can be written as h cross L plus. So we have proved that Lz L plus is h cross L plus. Number 3 is we have to prove that L plus L minus is 2h cross Lz. So this can be written as Lx plus Ly and Lx minus Ly. We have to prove that this thing is equal to this. So this can be expanded as Lx then minus I Lx Ly. This can be expanded as plus I Ly Lx, and this can be expanded as minus I Ly Ly. So these two terms are 0. This is 0. This is 0. So we can write Lx Ly is I h cross Lz plus I. Ly Lx is minus I h cross Lz. So this will become minus I square is plus 1. So it's h cross Lz. This will be plus h cross Lz. So this will become 2 h cross Lz. So we had to prove that L plus L minus operator is 2h cross Lz. We have proved that it is 2h cross Lz. So the first one was repeated, second was very easy, third was very easy. Now the next one is the fourth one is, actually it was misprinted in the paper, so somebody who had solved it would know that this was actually for L plus L minus is L square minus Lz square plus h cross Lz. So we can write L plus L minus as, so L plus is Lx plus Ly, L minus is Lx minus Ly. So you have to prove that this thing is equal to this. So this can be written as Lx square minus I Lx Ly plus I Ly Lx, and this is minus I square is plus 1, so it's plus Ly square. So this can be written as Lx square plus Ly square, and if we take I out of it, this will become Ly Lx minus Lx Ly. So we know that L square is Lx square plus Ly square plus Lz square. So Lx square plus Ly square can be written as L square minus Lz square. So this thing can be written as L square minus Lz square plus I, and this is nothing but bracket Ly Lx. Now it is L square minus Lz square plus I. Ly Lx, Lx Ly is I h cross Lz, so it's minus I h cross Lz. So this is L square minus Lz square. It's minus I square is plus 1, so plus h cross Lz. So we have proved that that this thing is equal to L square minus LZ square plus H cross LZ. Very easy. 20 marks for this. There are 4 identities, तो सबके मिला के 20 मार्क्स आपको मिलेंगे. नेक्स्ट क्वेश्चन इज, उससे पहले हम जरा सा पानी पी लेते हैं. Next question is that we have, it's question number 2 part B, it's for 15 marks, very easy, 15 marks. So it says that we have ground wave function of the harmonic oscillator, which is sin naught x is m omega or h cross pi power 1 by 4 exponential minus m omega x square over 2h cross. So we have the ground state. Now we have been asked that at which point the probability density is the maximum. So we can find it very easily. The probability density can be written as sin naught x square. So this will become m omega root m omega over h cross pi, and this will become e power, this will be square, so 2 will be cancelled out, it will become minus m omega x square over h cross. So we have the function, probability density function, so we can plot the probability density actually. So if you plot it, you will find that the probability is like that. This is the bell curve. So px has been plotted. Actually it will be symmetric. So px has been plotted. Now we can see that the dp by dx, we have to set dp by dx is equal to 0. So if we differentiate it, there will be a factor of 2x ahead, and if we put this is equal to 0, we will find that x is equal to 0. So x will be, at x is equal to 0, we have the probability density, which will be the maximum. We can check it, that second derivative due to p over dx square is less than 0 here. So we have the answer for question number 1 will be the p max is at x is equals to 0. And the second part is, what is the value of this maximum probability, p max? So we can plug x is equal to 0 in here, so this term will become 1. So p max is simply root m omega over h cross pi. So this is the maximum probability for this wave function. Very easy, very simple, very beautiful function, very smooth curve we have here. Okay. Now we have the next question, question 2 part C. It is very easy again, it's for 15 marks. It says that assuming the potential seen by a neutron in nucleus to be one-dimensional, and it is a rigid, infinite rigid wall potential of length 10 to the power minus 15 meters. So very easy again. It says the length is 10 to the power minus 15 meter, and it's one-dimensional, and we have one electron and one neutron. So actually there are 2 questions. So we have to find what is the energy for electron first in ground state, then for neutron. So we know that energy for ground state can be written as E1 is h square over 8ml square for this potential, n square h square over 8ml square, n is 1 for n is equal to 1. Now for energy for electron, we have to write h square over 8 mass of electron into L square. So for electron, the first part is for electron, so it is 10 to the power minus 15 square If we put all the values here, we will find it to be around 376 giga electron volts. This will be the energy for electron. And the part 2 is we have to find energy for neutron. This will be h square over 8 m neutron 10 square minus 15 square. So we have been asked the energy for neutron. This will come out to be around 204 mega electron volts. So these are the two answers. This was asked for 15 marks, very easy. So this was around 400 marks. This was for quantum mechanics. So we can see that in 2024, quantum mechanics is quite easy. The portion was very easy and it was scoreable. Thanks. Thank you very much.